this is JG and I am here with Joystock. If you have been following banking, investing or cryptocurrency over the last 10 years, you may have heard the term blockchain. Blockchain is an especially promising and revolutionary technology which reduces risk, stamps out fraud, and brings transparency in a scalable way for myriad users. Today my story is about blockchain technology, which is more simply defined as a decentralized distributed ledger that records the provenance of a digital asset. Before I start, as usual, I request you to subscribe to my channel. Hey, this is going to get bigger by the day, so hit the notification bell icon to keep in touch and keep a tab on my future episodes. Please also like or dislike and put in your valuable comments. Do share my content if you like them. Now, to start with, what is blockchain technology? Blockchain, sometimes referred to as distributed ledger technology or DLT, makes the history of any digital asset unalterable and transparent using decentralization and cryptographic hashing. A simple analogy for understanding blockchain technology is a Google Doc. When you create a document and share it with group of people, the document is distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to the document at the same time. No one is locked out awaiting changes from another party, while all modifications to the doc are being recorded in real time, making changes completely transparent. Of course, blockchain is more complicated than Google Doc, but analogy is apt because it illustrates critical ideas of the technology. Blockchain is specific type of database. It stores data in blocks that are then chained together. And incoming new data is entered into a fresh block. Once the block is filled, it is chained onto the previous block, which makes the data chained together in chronological order. Different types of information can be stored on a blockchain, but the most common use is as a ledger for transactions. In case of bitcoins, blockchain is used in a decentralized way so that no single person or group has control. Rather, all users collectively retain control. In case of decentralized blockchains, the data entered is irreversible. Now, let's come to the point. How does blockchains work? Blockchains consist of three important concepts: blocks, miners, and nodes. Every chain consists of multiple blocks, and each block has three basic elements. The data in the block, a 32-bit whole number called the nonce, randomly generated when a block is created, which in turn generates a block header hash. The hash is a 256-bit number wedded to the nonce. When the first block of a chain is created, a nonce generates the cryptographic hash. The data in the block is considered signed and forever tied to the nonce and hash unless it is mined. Miners create new blocks on the chain through a process called mining. In a blockchain, every block has its own unique nonce and hash and references the hash of the previous block. So mining a block is not easy, especially on large chains. Miners use special software to solve the incredibly complex math problem of finding a nonce that generates an accepted hash. Because the nonce is only 32 bits and the hash is 256, there are roughly 4 billion possible nonce hash combinations that must be mined before the right one is found. When that happens, miners are said to have find the golden nonce. Said to have found the golden nonce, and their block is added to the chain. One of the most important concepts in blockchain technology is decentralization. No one computer or organization can own the chain. Instead, it is distributed ledger. Via the nodes connected to the chain. Nodes can be any kind of electronic device that maintains copies of the blockchain and keeps the network functioning. Every node has its own copy of the blockchain, and the network must algorithmically approve any new mined block for the chain to be updated, trusted, and verified. Since blockchains are transparent, every action in the ledger can be easily checked and viewed. Each participation is given a unique alphanumeric identification number that shows their transaction. Now, we'll come to the history of blockchains. In spite of being a fairly new technology, already boasts a rich and interesting history. This is about blockchain. The following is a brief timeline of some of the most important and notable events in the development of blockchain. In 2008, Satoshi Nakamoto, a pseudonym for a person or group, published a peer-to-peer electronic cash system named Bitcoin. The next year itself, the first successful Bitcoin transaction occurred between computer scientist Hal Finney and the mysterious Satoshi Nakamoto. In 2010, Florida-based programmer Lastio Hanises made the first ever purchase using Bitcoin of 2 Papa John's pizzas for 10,000 Bitcoins, worth about $60 at that time, and worth about $80 million today. The year 2011 saw the parity of cryptocurrency and US dollar, and Electronic Frontier Foundation, WikiLeaks, etc. started accepting Bitcoin as donations. 2012 saw blockchain and cryptocurrencies introduction in popular television shows like Good Wife, and early Bitcoin developer Vitalik Buterin launched the Bitcoin magazine. Bitcoin market cap surpassed $1 billion, and Bitcoin reached a valuation of $100 for first time in 2013. Ethereum project was also published by Vitalik Buterin, suggesting other possibilities of blockchain besides Bitcoin in the same year. 2014 saw gaming company Zynga, the Las Vegas Hotel, and Overstock.com accept bitcoins. Buterin's Ethereum project got crowdfunded via an initial coin offering, that is ICO, raising about $18 million in bitcoins. A group of over 200 blockchain firms was formed and PayPal announced Bitcoin integration. By the year 2015, number of merchants accepting Bitcoins exceeded 100,000. In the same year, Nasdaq and San Francisco-based Bitcoin company teamed up to test technology for trading shares in private companies. Around 2016, IBM announced a blockchain strategy for cloud-based business solutions, and Government of Japan recognized the legitimacy of blockchain and cryptocurrencies. The year 2017 was a landmark year for blockchain technology as Bitcoin valuation reached $1,000 for the first time, and cryptocurrency market cap touched $150 billion. In the same year, JP Morgan CEO Jamie Dimon gave the ledger system a vote of confidence. Bitcoin reached its all-time high at $19,783.21. And Dubai announced that its government will be blockchain powered by 2020. In 2018, Facebook committed to start a blockchain group and also hinted at possibility of creating its own cryptocurrency. IBM developed a blockchain-based banking platform with Citi and Barclays signing on. Next, we'll come to blockchain applications. Blockchain has nearly endless applications across industries. Walmart, Pfizer, AIG, Siemens, Unilever, and host of others have already incorporated blockchain. IBM has created its food trust blockchain to trace the journey that food products take to get to its location. If a food is found to be contaminated, then it can be traced all the way back through each stop to its origin, potentially saving lives. Suppliers in food industry too can use blockchain to record the origin of materials that they have purchased and verify the authenticity of their products along with such common levels as organic, local, and fair trade. Perhaps no industry stands to benefit from integrating blockchains into its business operations more than banking. Financial institutions only operate during business hours, and transactions can take 1 to 3 days to verify. Blockchain, on the other hand, never sleeps. By integrating blockchain, consumers can see their transactions processed in as little as 10 minutes, regardless of holidays or the time of day or week. In the stock trading business, for example, given the size of the sums involved, even the few days that the money is in transit can carry significant costs and risks for banks. European bank Santander and its research partners put the potential savings at $15 billion to $20 billion a year. Capgemini, a French consultancy, estimates that consumers could save up to $16 billion in banking and insurance fees each year through blockchain-based applications. Blockchain forms the bedrock of cryptocurrencies like Bitcoin. The US dollar is controlled by the Federal Reserve. Under this central authority system, a user's data and currency are technically at the whim of their bank or government. If a user's bank is hacked, the client's private information is at risk. If the client's bank collapses or they live in a country with an unstable government, the value of their currency may be at risk. In 2008, some of the banks that ran out of money were bailed out partially using taxpayers' money. These are the worries out of which Bitcoin was first conceived and developed. Healthcare providers can leverage blockchains to securely store their patients' medical records, which provides patients with a proof and confidence that the record cannot be changed. This could be encoded and stored with a private key so that they are only accessible by certain individuals, thereby ensuring privacy. If you have ever spent time in your local recorder's office, you will know that the process of recording property rights is both burdensome and inefficient. Today, a physical deed is manually entered into the country's central database and public index. In the case of a property dispute, claims to the property must be recorded with the public index. This process is not just costly and time consuming, it is also riddled with human error. Blockchain has the potential to eliminate the need for scanning documents and tracking down physical files in a local recording office. Property ownership can be stored and verified on the blockchain, assuring owners that their deed is accurate and permanently recorded. Another hugely evolved concept is a smart contract, which is a computer code built into the blockchain to facilitate, verify, or negotiate a contract agreement. Smart contracts operate under a set of conditions that users agree to. When those conditions are met, the terms of the agreement are automatically carried out. Say, for example, a tenant would like to lease an apartment using a smart contract. The landlord agrees to give the tenant the door code to the apartment as soon as the tenant pays the security deposit. Both the tenant and the landlord would send their respective portions of the deal to the smart contract, which would hold onto and automatically exchange the door code for the security deposit on the date the lease begins. If the landlord doesn't supply the door code by the lease date, the smart contract refunds the security deposit. This would eliminate the fees and process typically associated with the use of notary, third-party mediator, or attorneys. Blockchains could also be used to facilitate a modern voting system. Voting with blockchain carries the potential to eliminate election fraud and boost voter turnout, as was tested in the November 2018 midterm elections in West Virginia. Using blockchain in this way would make votes nearly impossible to tamper with. The blockchain protocol would also maintain transparency in the electoral process, reducing the personnel needed to conduct an election and providing officials with nearly instant results. This would eliminate the need for recounts or any real concern that fraud might threaten the election. Financial service technology or fintech is one major area where blockchain is currently shining brightly. At a high level, blockchain removes third parties from the equation. In other words, a financial transaction on a blockchain needs no bank or government backer, and that means no fees. One Accenture report claimed blockchain technology could reduce infrastructure cost for 8 of the world's 10 largest investment banks by an average of 30%. JP Morgan has created arguably one of the largest blockchain payments network to date, the Interbank Information Network, or IIN. The financial services company announced in late 2017 that the Royal Bank of Canada and Australia and New Zealand Banking Group Limited had joined INN, representing significant cross-border payment volumes. MasterCard in late 2017 also launched its own blockchain network to enable partner banks and merchants to make cross-border payments faster and more securely. Peer-to-peer foreign exchange provider ClickX has created a new blockchain-based payment system capable of processing cross-border payments in seconds. Now, let us discuss the pros and cons of blockchain technology. Down here, I've listed the pros and cons of this unique technology for a better understanding of its potential. Pros: improved accuracy by removing human involvement in verification. Next, cost reduction by eliminating third-party verification. Next, decentralization makes it harder to tamper with. Then, transactions are secure, private, and efficient. Then, transparent technology. And next is the point that it provides a banking alternative and way to secure personal information for citizens of countries with unstable or underdeveloped governments. Now about the cons. First, significant technology cost associated with mining Bitcoin. Next is low transactions per second. Then comes history of use in illicit activities. And finally, regulations. As a buzzword on the tongue of every investor, blockchain stands to make business and government operations more accurate, efficient, secure, and cheap with fewer middlemen. As we prepare to head into the third decade of blockchain, it is no longer a question of if legacy companies will catch onto the technology. It is a question of when.